Hello, welcome. This is your lesson on 6.1 area and perimeter, the advanced version. I know area and perimeter by itself sounds like a pretty easy lesson, but this section here we're going to focus in on some of the more difficult types of area and perimeter problems. This next slide you may not need to get in your notes because it's something you're going to need to get on your next worksheet that I'm going to give you. I just copied the top of the worksheet, and these are the blanks you'll fill in. You can either write them in now in your notebook and then just fill in the blanks when you get the worksheet, or you can just kind of move the video right to the answers to all these and fill them in when you get your worksheet. So real quickly running through it, a brief statement that describes perimeter. Perimeter of a polygon or perimeter of a shape is the distance around. So all you do is you sum, it's an S, sum the lengths of the sides. Sum means add. So all you're really doing is adding up all the lengths of each side of a polygon to get the perimeter. Perimeter means distance around. What's the equation for the perimeter of a rectangle with lengths L and W? So I mean, just drawing it down here, here's your rectangle, this is L, this is W. So basically the perimeter is going to be 2 of those L's, I'm going to put that in cursive to kind of help you, plus 2 of the W's. Because there are 2 W sides and 2 L sides, because rectangles have opposite sides which are congruent. What's the equation for the area of a rectangle? Now, area is how much you can fit inside of a rectangle. If you're painting, say, a rectangular shape, area of a rectangle is pretty easy. That's length times width. Equation for area of a triangle. Area of a triangle is pretty much similar to the rectangle, except it's cut in half. So it's 1/2. You could say length times width, but usually with a triangle they call it the base and the height. The key here is that the height and the base need to be perpendicular to each other. If you have a slanty triangle, you're going to have to use some other means to kind of figure out the height. Equation for the perimeter of a circle, but when it's perimeter of a circle or distance around, we call that the circumference. Circumference of a circle is either 2 pi r, which I like to use, or if you have the diameter, you could also call it pi times the d, because the diameter is 2 times the radius. It's the equation for the area of the circle. That's our famous pi r squared. And if the length of a side is measured in centimeters, what are the units for the area? Area are square centimeters, usually designated by the little 2. And if the length of the side is measured in centimeters, what's the volume? And we'll be getting into that more heavily with the next lesson. That would be centimeters cubed. So this is how you fill out the top. The unfortunate thing is there are going to be some odd shapes that don't fit all of these little criteria here. So this is going to be a tricky lesson where I couldn't really give you every single thing, or else this video would be like 30 minutes long. So there are times where you might have to Google, say, the area formula for some weird shape like a parallelogram or a trapezoid or something like that. But this is just the background and the major formulas you'll need. Now moving, and when I was putting these examples together and looking at the learning targets you'll have to do, there's a lot I could do. So I just put 2 of the more complicated examples, and just understand that you're going to have to kind of mess with a lot of the other shapes and try to split them into shapes, or maybe you might have to do a little bit extra research by Googling some topics. So what I'm going to do here is I need to find the area of this kind of weird shape right here. It's not a traditional rectangle, it's not a traditional trapezoid or any kind of geometry shape, but if I notice, it is a combination of 2 of them. It is a big rectangle here with a circle cut out. So mainly for this kind of thing, for area, I'm just going to take the area of the rectangle, and I'm going to take away or subtract this half of a circle. That's the plan. So the rectangle is going to be just our standard length times width, which in this case is going to be 13 times 6. I know that's a little blurry to read, but that's a 13 and a 6. So the width is 6, the length is 13. Get out my old handy calculator if I'm not sure, and 13 times 6 is 78. So that's the area of the rectangle. Then this half circle, the formula is pi r squared, and then you got to take half of that because it's not a full circle, it's a half circle, so I'm going to divide by 2. So I take pi, and the radius here is a little bit tricky. Changing colors here, the radius is from the middle to the outside. So if the whole thing is 6, then this little spot right there is going to be 3. So it's pi times 3 squared divided by 2. And 3 squared is 9, so you got 9 pi divided by 2. Now for the area of the whole shape, you just take your rectangle, 78, minus 9 pi over 2. I'll take this as an acceptable answer, and it kind of depends on the type of test you're taking, but sometimes you might be taking a multiple choice test and this appears in the answer, and sometimes you're not. Sometimes the answers might appear as decimal answers. So if they do appear as decimal answers, you're going to have to type it into your calculator. Just takes a moment to do that, like I'm doing right now, and I get 63.86. And then you just have to check your solutions and what's available to know if you need this, what we call exact form right there, or approximate form, which is this one right here. Let's do our units. This is in yards, so this would then be in, this is area, so it's square yards. All right, moving forward, I've got one more question because a couple of these will appear on your worksheet. Is about the area of this isosceles trapezoid. Now, you could kind of Google the trapezoid formula if you wanted to, or you could break this up into two different shapes. Hopefully you remember what isosceles means. Isosceles means that the base angles are the same. So this one right here is 60 degrees, and this one right here is 60 degrees. So for this problem here, what I'm going to end up doing is I'm going to split it into a rectangle, I think. Could be a square, but I'll just call it a rectangle. And then the triangle, and I'm going to double that because these triangles are the same here. So I'm going to start with the red picture, and I'm going to do the rectangle. However, with the rectangle, I don't really know the length of that side. So I'm going to use the triangle, and when I find the triangle side, it'll also be the same as the rectangle side. So kind of drawing that green triangle down here again, you have a right angle here, you have an unknown here, which I need for both the triangle and the rectangle, and then you have 60 degrees right there. So now you need to go back to everything we've learned all year. 60-degree triangle, and you know this is 4 down here, so you're going to do opposite over adjacent, which is tangent. So TOA, so you're going to do tangent of 60 degrees equals opposite, which is x, or I don't know, over 4. So x equals whatever 4 tangent of 60 is. Plugging that into my calculator, I think that's 6.928. I like to use a lot of decimals in the middle of a problem. So that basically is going to give me my height of my both triangle and rectangle. So the rectangle's formula is length times width, and the length is going to be 10. The width is going to be this number I got, 6.928. Multiplying that out, 10 times 6.928 is 69.28. And I'm going to put a little kind of circle around this, knowing that that's part of my shape. And then when I change to green and I do this triangle here, triangle is 1/2 base times height. The base is 4, the height is 6.928, so it's half of 4 times 6.928. It should be a 6.928 And multiplying that all out, I get 13.856. However, there's one of them over here, and there's one of them over here. So I need two of them. So you double it. And that'll give you 27.712. So those are the two triangles, and then to get the area of the entire shape, you just add those. So total area will be equal to, let's change this to brown so we can kind of see the final answer, whatever 69.28 plus 27.712 is, and I think that's 96.992. Don't forget your units. There are no units, so I'm just going to put UN for units, and this is square units. Now, I didn't really cover perimeter, but for perimeter for this one, if you were to do that, if I asked you that, you would just add these two tens. That'll give you these two, and then you need to get this side and this side. These are both 4, so for perimeter, if I needed to do it, it would be 10 plus 10 plus 4 plus 4, and then you have to add up these slanty sides. So I'm just going to put an SL for slant plus SL for slant. I'm not going to do it, but this side right here and this side right there can both be found using trigonometry again. There are many more ideas in this lesson, and you may have to do a little Google search if there's a shape that's weird for you and you're not sure what to do, but we'll work on it in class. Thanks for listening.